All right, you've got your circuit built and you've got the electrodes wired into the circuit. We're going to power it up, so plug in your 9-volt batteries. What you'll now do is take your multimeter, put it on DC volts and measure the voltage from electrode to electrode. Check all 3 electrodes. There shouldn't be any more than a volt or 2 on any electrode. In fact, it should read less than half a volt. But you might get some stray voltages in there. So hold the negative lead on one electrode, then touch the positive lead to the other 2. Now switch the negative lead to one of the other 2, and then repeat the process. And then do it again for the last lead. Okay, so now you know you haven't made a major goof somewhere at least, and when you wire yourself up, you're not going to get that wonderful sensation of electrons crawling through your skin. So go ahead and hook up the electrodes in place on your arm. Okay, so once you've got that in place, flex your pipes. Flex them hard. Flex them a little bit. See how well you can control the position of the servo. Now, if your servo is not moving, we'll go to troubleshooting. If it is working, awesome. So let's say it's not working. If a circuit is not working, what's the first thing we always check? The power supply. First, check all your battery leads. Make sure you've got everything hooked up correctly. Second thing to check power-wise, did you reverse the connections on the op-amp? Remember, the positive supply is on pin 4, the negative is on pin 11. It's easy to get those 2 reversed because most microchips, the positive is on the top, negative is on the bottom. Do you have the negative wire from your 6-volt battery pack connected to ground? You didn't accidentally connect it to the negative 9 volts of the dual supply, did you? And your battery pack is turned on, correct? Now, break the circuit down into sections. It's easy to get the inverting and non-inverting inputs mixed up. Double check your wiring. Make sure you have the resistors and the wires going to the right pins on each of the op-amps. Notice that the op-amps are wired in a pattern going outward from the center. From the middle pin, you have the non-inverting pin, then the inverting pin, then the output of the op-amp. Another thing, play with the gain. I found the gain was really sensitive, and if you turned it too far, you lost all functionality. Try adjusting the gain and seeing if that helps. If that hasn't worked, now use your multimeter to test each section. You'll need to keep the electrodes wired up for this because you actually need to test the functionality of the circuit. So hopefully if you discover a miswiring, you don't give yourself a shock rewiring it. With your multimeter's negative lead connected to ground, put your multimeter on AC volts. putting the multimeter lead on the output of the third op amp, you should get a fairly substantial AC voltage there, which increases when you flex your pipes. If it does not, you've already narrowed down the problem to the first 3 op amps or the gain. There's a miswiring somewhere. Did you use the correct value of resistors? Did you accidentally run one of the resistors to the negative supply instead of ground? Did you run the voltage dividers the wrong way on the inverting and non-inverting inputs? Now measure the AC voltage coming into the 4th op amp. Okay, you should have a good AC signal of at least several millivolts. If you have signal on the output of your 3rd op amp, but none on the input of your 4th, then there's a problem with the coupling capacitor. Either it's dead or not going to the right place. You should now get a very significant AC voltage coming out of the 4th op amp. At least several volts. If not, check the resistor setup. Did you use the right values? Did you get any of the pins mixed up? Now switch your multimeter to DC volts. And measure the voltage at the big honkin' capacitor. That should show a very responsive voltage going up and down as you flex your pipes. Double check the polarity of your diode. Do you have the diode going the right way? You should be getting a positive voltage across the capacitor. Finally, check the servo controller circuitry. Actually disconnect the op amp circuit from pin 5 and replace R12 with your 10K pot in series with a 5.6K resistor, just like we had before. Is the servo controller circuit working? It should work by itself, and thus the signal coming out of the op amps should simply vary the servo pulse width modulation signal. So if it's not working, check that circuit. There's something wrong there. So once again, I want to point out how this is all strictly analog electronics. And yet look at how powerful even simple analog electronics can be. In the next module, when we get into digital electronics, we can combine our muscle sensing with a computer to use it in even more powerful ways. We can perform on-the-fly calibration, use your muscles to control things on the computer screen, or read multiple muscles to control a robot. Really, the biggest limitation there is your imagination. So have some fun with this circuit. Once you get it going, maybe experiment with it and try to pick up signals from smaller muscles, like the muscles from your fingers and stuff. Disconnect the servo driver circuit. Run the output of the op amp through a coupling capacitor, through your speaker to ground, and listen to the sound of your muscle signals.